Good morning everyone. I am Syed Akhlaq from Institute of Space Technology, Pakistan, and we have developed variable gesture-based human-computer interaction system. The system lets the user to interact with computer using his hand gestures. When you think of a computer, what sort of images come in your mind? Perhaps you see something like this with a display screen, a keyboard and a mouse. Or even a laptop with its display screen, keyboard and a touchpad. Or you might even think of a Surface table. But all of these are actually merely the tools that we use to interact with computers. These are the tools that we use to input and output information to computers. And in the next coming slides, I would like to emphasize on the fact that these tools do not harness the full potential and power of computers. First, let's see some of the trends in human-computer interaction and see how the conventional interfaces cope with those trends. First is mobility. The flood of information that we have these days, we want to have constant access to information. We want our computers to be with us all the time so that we can input and output information. So this need of mobility has brought about miniaturization of computers. We started with these huge giants and now we have these cute little machines that can easily fit in our pockets. But with this miniaturization, the operational area of the device is reduced. So this reduction in the operational area causes a hindrance in the interaction with the computer. The processing power of the computer has increased and are becoming smaller and smaller with every passing day. But the only limitation in this interaction and miniaturization are the tools that we use to interact with the computer. Secondly, of trend is having intuitive interaction. In the market we see these big Surface tables. The operational area is very wide, so in this way the user can interact with the information in a very intuitive and natural way. But unfortunately they are very bulky and they are not mobile. So the currently available interfaces in the market either lack in mobility or in intuitiveness. They don't provide us both in one package. Now let's see, we have this image and we want to flip it first, then zoom in and then zoom out. Fairly simple process, and let's try out our conventional interfaces. With the keyboard, you need to press Ctrl K 2 times, then Ctrl equal and then Ctrl underscore to do the stuff. And with the mouse, first you need to right click it, then left click on the counterclockwise rotation 2 times and then right click and then zoom in and then zoom out. Now I come from a country where 70% of the people are illiterate. Now try and teach this to them. Try and teach this to a 3-year-old. Try and teach this to a 70-year-old man who doesn't know about computers. And now let's try it with our developed system. You can do this stuff with a simple gesture of hand in air with a scale and rotation. And this is how our developed system looks like. We have a camera and a pocket projector. The projector projects the information on any wall, any surface, so we don't need any output screen. Any wall and any surface, which is a clear one, can be converted into an interface with this projection. And the user can interact with this information using his bare hands. So in this way the interaction becomes very intuitive and very natural, and the user is also mobile. The user can go wherever he wants. So in this way our variable gesture based interaction provides us mobility and intuitive interaction in one package. Now these are some of the achievements of our project. We have an IEEE International accepted paper in a conference on signal and image processing in Malaysia, and one in Paris, that is International Conference on Machinery in 2011. We have developed some applications to showcase the potential and usefulness of the developed system. First one is the picture browsing. Then intuitive web lifting. Now let me describe how it works. So basically we need to do four things. First we need to detect the hand of the user, then track it, and then recognize the gesture drawn with the fingertip of the user. And the detection of hand is the most difficult one. And why it's difficult? Because human hand comes in all forms and shapes. And there is a very wide variation in skin color tone, because people are belonging from different ethnic background. There is a very wide variation in the skin color tone. Thirdly, the ambient light changes the apparent color of the hand, and the detection of hand in a cluttered background is also very tough and is still a research area. But we have done detection of hand in a simple background, not cluttered background. So we use skin color along with hand features for the detection of hand, and we use hard-like features to detect the hands. Once the hand is detected, we need to track it, and we use camshift tracking to track the hand. And this is how it works. First, a frame is captured with the webcam and the hand is detected. Once the detection phase is, or now the detection phase is over, and we start the tracking mode. In the tracking mode, no detection is done, and we calculate a probability of skin color in the next frame, and from that probability we estimate the hand region, and on that estimated region we do skin detection. And the same process goes on unless the hand goes out of the frame of the camera, and then the detection mode starts. This is a demo of hand tracking. Now coming to fingertip detection, we use convex hull to detect the fingertips. Once the hand is detected, using the convexity defects, we figure out the fingertips. And this is the demo of fingertip detection. The green circle indicates the fingertip. Now we have defined some postures here. A closed fist indicates a pointing gesture. Open fist also indicate a pointing gestures. If you point your index finger, it means a click, and if you point your index and middle finger simultaneously, it corresponds a right click. And now coming to this gesture recognition, we have used single stroke gestures because they are easy to draw for the user and they are easy to recognize. We have defined some gestures, that is rotate and scale gesture, window closing gesture, map application opening and drawing application gesture, right and left gestures. And this is the demo of gesture matching. The user here will draw a C, and the program will recognize that it's a C. Now the developed system is very compatible. You just need a webcam and a software, and the device goes on a gesture interface. If you don't want a projector because of the intensity issues, you just need a webcam and a software So in this way you can convert the front end of any device to a gesture-based interface. The dual system is pretty much reliable, but still needs improvement. It's still a work in progress, and we are looking to improve the results. That's all from our side. Thank you.